project has been focused on the causes and consequences of coral decline throughout the Florida Keys. And specifically, we've done everything from working with different fish behaviors and how that can influence the reefs, as well as trying to conserve corals and transplant new coral fragments for future reefs.
As you may or may not know, coral reefs have been declining across pretty much the entire Earth, and especially in the Florida Keys. So if you look, these are reefs from 1950 to 1985, and these are 1985 to present. So these older reefs, you know, they're full of hard coral, not a lot of algae, whereas now there's a lot of algae, there's like a lot of proliferation, not as much hard coral that's actually present. So one thing that we wanted to look at were some of the effects that herbivorous reef fishes are having on the reef, and the things that affect those herbivorous reef fishes. So we looked at one specific type of fish called the neon goby. And the neon goby, they're cleaner fish that actually eat parasites off of herbivorous reef fish, which has been shown in the past to really like increase their productivity in eating macroalgae.
And what we found was that lobster dentine behaviors are very plastic. They change all the time. We really can't influence them as much as we think that we could. So this is really important to know because they can just change and do whatever they want.
Right now, we're actually moving farther along in the project. We have made peptides with peg chains on them. We have purified them, and now we are moving hopefully towards testing their activity. So now that we've made them, we want to make sure that these pegs do what we think they do. So we want to make sure that they are extending the half-life by how much they're extending it, making sure that they don't interfere with any of the activity of the peptides. And that's like kind of where we're moving towards now.
So we're also doing another part that's sort of a proof of concept, and we're taking something that's slightly longer than the one shown here. We're taking a peptide, and it forms a helical structure. And so what we want to know is, are these peg chains actually affecting that peptide's ability to form that helical structure, or maybe it stabilizes it? And so the idea with this is that not all peptides are going to just be linear and straightforward. And so we want to make sure that this concept can be applicable to many different types of peptides.